Hello everyone, welcome to my channel Let's Understand. I am Amal and a software engineer. Let's understand our today's topic, concepts of programming language. If you did not watch my previous video, please go and watch once. You will get definitely some clarity from that. Let's start. Programming domain. Programming have a different type of domain. That's like what type of programming you want to do. Let's discuss one by one. First, it was scientific application. When you want to develop the application, you need to choose your programming language. So, on the basis of this different term, the programming is defined. So for scientific application, large number of floating point computation need to be done on the basis of array on other things. So Fortran, formula translator, this is the one of the programming language used for scientific application. For business application, in business application we need to produce the reports for different type of numbers, of decimal numbers and characters. So COBOL, common business oriented language, this is the one of the programming language for business application. For artificial intelligence, sample rather than number manipulated, use of linked list processing. System programming need efficient because of continuous use. So see, suppose that when we need to talk with the direct machines, that is CPU. So that type of programming is done on the C. Web software, collection of language, or we do browsing on the web browser. Everything is a web application. So for this we have markup. Example is XHTML, extensible hypermarket language. Scripting, that is the PHP, hypertext preprocessor. HTML embedded script language, general purpose, example Java. Let's discuss how programming language is. Let's discuss the evolution of programming language. On the screen, you are able to see the snapshot of programming language history. So, if you see one by one, there is a Fortran 60, Fortran 77, Fortran 90, and this is the evolution of the Fortran. Just like a COBOL used for I already explained the COBOL used for common business oriented language. Fortran used for formula trajectory. Algol, IL, Jovial, Semula Talk, Java, Efficient. If you are from the computer science background, you definitely know the Pascal, ATA 95, Spark ATA, BPCL, C, C++, C++ standards, C#, Java, list processing, protect common lists, clause, schema, Haskell is a functional programming. So this is the basic. If you want to explore more, you pause the video and go one by one. Now come to the language evaluation criteria. So now you understand the programming. So how you evaluate which program is the best, which program is not. So it depends on the different parameters. First is the readability. The ease with which programming can be read and understood. Writability. The ease with which language can be used to create program. Reliability. Conformation to a specification, that is performed to its specification. Cost, to ultimate total cost of writing that program. Evaluation criteria, reliability. Let's go one by one in details. So overall simplicity. A programming language is called simplified on the basis of this parameter. A manageable set of features and construct. Minimal feature multiplicity. That means A equal to A plus 1, A plus 1, A plus plus, A plus 1. Both do same work in this different scenario. Minimal operator overloaded. Example, plus for both integration and floating point. That means when you need to add integer and floating point plus word. Second is orthogonality. A relatively small set of primitive construction can be combined in a relatively small number of ways to build a control and data structure of the language. Second, every possible combination is legal. That means, example, a language has 4 primitive data types and 2 operators, array and pointer. A large number of data type structure can be defined. Data types, presence of adequate predefined data types. Just like when you use here A is a variable, and what type of this A is called a data type. Either it is int type or float type. Now come to the syntax consideration. Flexible identifier form, that is flexible combination. When you declare the identifier, you have the flexibility or not. A special words and method of forming compound expression. Example, while, class, for, etc. From and meanings, self-descriptive construction, meaningful keywords supported. This all terms called under the readability. Now come to the writability. Simplicity and orthogonality. Few constructor, a small number of primitive, a small set of rule for combining them. That means there is a few number of constructors available, a small number of primitive, and you have need to follow only some special rules to combine all of them. Support of abstraction. The ability to define and use complicated structure or operation in way that allow detail to be ignored. Example, a subprogram to implement a short program. A subprogram to implement a short program without abstraction, the short code have to be replicated in all places where it was needed. Expressivity. A language had relatively convenient way of specifying computation. Example, A++ is more convenient than A equal to A plus 1 in C. This basic means that whenever you need to write on a specific statement or condition or line, so how you are able to express them. Just like here A++, that means you are increasing A by 1, or you are writing A equal to A plus 1. So instead of this one statement, you can write this as a 1. Now come to reliability. Type checking, exception handling, aliasing, readability and writability. In type testing for the type error in given program, either by compiler or during program execution. When you write a program in C, C++, Java, there is a compilation error. So whenever you are writing you done any syntax error or any declaration mismatch, it will check over there. Exception handling. How much your program have the facility to handle the exception, intercept runtime error, and take correct measure and then continue. Aliasing. Having 2 or more distinct name. that can be used to access the same memory cell. Two pointers set to the point on the same variable. This is a simple example for aliasing. Readability and writability. A language that does not support natural way of expressing algorithm will require to use unnatural approach and hence reduce the readability. The easier program is to write, the more likely is to be correct. Now come to the other criteria: portability, generality, well definition. In portability, the essay which program can be moved from one implementation to another. In generality, the application to be wide range of application or not. Well definition, the competence and presence of the language is official definition. Now come to the on point: influences on language design. Computer architecture, primary methodology. How what need to be take consider when you design any programming language. So computer architecture or programming methodology. In computer language are developed around the prevalent computer architecture known as the non-Newman architecture. New software development methodology. Example: object-oriented software development lead to new programming paradigm and by extension new programming language. Computer architecture influence continue. Well-known computer architecture is non-binary. Imperative language must domain because of one known computer. Data and program are stored in memory. Memory is separate from CPU. Instruction and data are piped from memory to CPU. Basic for imperative language is variable model memory cell, assignment of statement model piping, and iteration of efficient. Now see the basic structure of the Newman architecture. There is some stack called memory. There is a store path, instruction, and data. This communicate with this central processing unit, which have the result of operation and instruction of data. CPU read the instruction of data from the memory in the control unit and do some arithmetical or logic unit, and result which produce is go to the again to the memory, and if that need to be output again, data come to the central processing unit and produce the output. This is the basic structure of the one Newman architecture. Fetch execute cycle on a non-binary architecture computer. So this is basic understanding how it's work. In first initialize the program in computer, repeat forever, fetch the instruction pointed by the counter, increment the counter, decode the instruction, execute the instruction, and repeat. Just like here. Read from here, again fetch the instruction from point to the computer, where particular point, that means suppose that this memory cell is read. This memory cell need to be read. So this point is pointed in control unit. That means to fetch the instruction and point by the computer. Increment the counter. Now when this line is read, counter is increment and stored. Now decode the instruction. When here this particular line is read by the control unit, it will be decoded, and after that it will execute. If that need to be provide output. If that need to be computational, it's go to the arithmetic logic unit and do, and after that again result pushed in the memory. This is the, and this whole process is repeat. So this is the basic structure. So now how programming will influences in time to time. So in our previous video we see that in 1940 there is a machine language is commonly used. In near about 1950 symbolic language come in the picture, and after that high level language come in the picture. So that from 1950 to 1960 simple application worry about machine efficiency. At that time, whenever we develop on any software, that time our main concern is to develop a software which provide the machine efficiency. Late 1960s, people efficient become important, readability become important, better controller structure become important. So a structural programming come in the picture, top down design and stepwise requirement come in the picture. Late 1970s sit for procedure oriented and data oriented programming. So data abstraction is the process by which data and program are defined with a representation similar to its meaning, semantic, while handing away the implementation details. Abstraction means that you have to know that this is happening, but how this is happening you don't need to care. This is basic example of abstraction. Metal 1980, object-oriented programming come in the picture. In this, the data abstraction, inheritance and polymorphism both come in the picture. Inheritance suggests an object is able to inherit characteristics from another object. I can explain inheritance with an example. Suppose that we need to let's take the mobile. What mobile have the features? Mobile have the camera features, mobile have the music player features, mobile have the video player features. So all the features have the different specific, suppose that camera have the only the clicking the picture features, and this is the specific features only for the camera, and that is inherited from the camera to the mobile, and mobile have that specific feature. So this is the basic example of inheritance. Polymorphism is a capability of an action or method to do different things based on the object that is acting upon. Now come to the language characterization. We characterize language on the basis of imperative, functional, logic, and markup language. So in imperative, its a central feature are variable, assignment, statement, and iteration. Include language that support object-oriented programming. Include scripting language. Include visual language. Example: C, Java, JavaScript, Visual Basic, .NET, C++, Python, etc. Functional. Main means of making computation is by applying function to given parameter. Example: Lisp, schema, Haskell, etc. Logic. Rule based. In this programming language categories, the things is rule based. Rule are specified in no particular order. Example: Prolang. Markup programming language, or it is also called programming hybrid. Markup language extend to support some programming. Example: JSTL, XSTL. Now come to the language design trade-off. When you design a language, programming language, what type of trade-off you going to face? Reliability versus cost execution. Example: Java demands all reference to array element be checked for a proper indexing, which leads to increased execution of cost. Readability versus writability. Example: APL provide many powerful operators and a large number of new sample, allowing complex computation to be written in concept programming, but the cost is of poor readability. So when you go to the APL, it provides the better writability and computational skills, but its readability is too low. Now come to the writability, that is flexibility versus reliability. Example: C++ pointers are powerful and very flexible, but are unreliable. Now come to the layer of view of computers. So in a small now come to the layer view of computer. I think you remember our previous video. I explained this picture some little bit, but here we can study more about this. So the operating system language implementation are layered over machine interface of a computer. If you remember our previous video, there one of the picture is hardware, where our operating system is run over that application software is run, and user will communicate with that. So this is the extra. So here we have the bare machine, that is the CPU. After that, micro instruction interpreter, operating system, this, and the basic of software which written either in ADA, in C, or Fortran, or C++, and Lisp, anything. Now come to the compilation. I already explained a little bit about compilation in our previous video. You can check out that. In compilation, translate high-level programming language, source language into the machine code language. Slow translation, fast execution. Compilation process has several phases. Lexical analysis convert character in the source program into lexical unit. Syntax analysis transform lexical units into parse-tree, which represent the semantic structure of program. Semantic analysis generate intermediate code. Code generation, machine code generated. That means this is the called machine code. This is the called our source code. So here one of the picture which explain compilation process. In previous video, I explained how actual C code is compiled from source code to machine code. So this is the basic structure of the every programming languages, not specific only for the C. We have the source program. We analyze this as a lexical analyzer. We again go and check the symbolic table, what the symbol table they have. Again, lexical units are go in the syntax analyzer. Again, syntax analyzer things go in check in the symbol table. Parse-tree to come in the picture. Intermediate code generator and semantic analyzer come. Symbolic table provide the details, and after that, if optimization is needed, it will go and optimize it. After that, intermediate code is come here, and code generator come in the picture. So if any symbolic things need to be taken care, it will fetch from the table, and after that, machine language come and it's generate that, and it will provide the result on the basis of input data. Additional components terminology. There is a load module, there is a link and loading module. If you know about the Java have the term class load time. So load time is also the basic requirement in any programming language. So load module, executable image, the user and system code together, linking and loading, the process of collecting system program units and linking them to the user program. Now come to the hybrid implementation system. A compromise between compiler and pure interpreters. That means when interpreter and compiler both will provide the facility of both. That is called hybrid implementation. A high-level language program is translated to an intermediate language that allows easy interpretation, faster than pure interpretation. Example: Perl programming are partially compiled to detect error before interpretation. Initial implementation of Java were hybrid. The intermediate from bytecode provides portability to many machines that has bytecode interpreter and runtime system together. These are called Java Virtual Machine, JVM. One thing you know that Java, we call it Java platform independent. You have the answer for that, why we call Java platform independent? Pause the video and think that. So now, JVM, that is Java Virtual Machine, is the only responsible guy who force or provide the flexibility to Java to machine independent. Now this is hybrid implementation of process. Source program go to the lexical analyzer. After lexical analyzer, syntax, and this is the same. And after intermediate code generation, intermediate code go to the interpreter. If input data needed, it will take and provide the result. Just-in-time implementation system. Initially translate program to intermediate language, then compile the intermediate language of the subprogram into machine code. When they are called, machine code version is kept for subsequent call. JIT system are widely used for Java programming. .NET language are implemented with JIT system. That is .NET language are implemented with the JIT system. Preprocessor. Preprocessor nothing but initial part of any programming. Suppose that preprocessor and micro, that is instruction, are commonly used to associate that code from another file is to be included. A preprocessor process a program immediately before the program is compiled to expand embedded preprocessor micros. That is before compiling start, preprocessor micro statement is got invoked. A well-known example in C preprocessor is expand, hash include, hash define, and similar micros. Now come to the programming environment. So you already created the program language. You know the how program language is decided. You know the how we design program language. You know the how we evaluate efficiency of programming language. Now come to the what is the programming environment. A collection of tools used in software development is called programming language. So suppose that you need to create one particular software. So for what programming language you need to develop for the software. What type of setup you need to do. This all the setup is called the programming environment. A collection of tools used to software. Your Unix, that means one operating system you need to use, an older operating system that, and tool collection. Nowadays often used through GUI, graphical user interface. Example CD, KDE, Geonomy that run on the top of Unix. Microsoft Visual Studio.NET, a large complex visual environment used to build web application and non-web application in any .NET language. NetBeans relate to Visual Studio.NET except for web application in Java. Now come to the summary. This is our ending point of today's video. The study of programming language is valuable for a number of reasons. Increase our capacity to use different constructs, enable us to choose language more intelligently, makes learning new language easier. Most important criteria for evaluating programming language include readability, writability, reliability, and cost. Major influence on language design have been machine architecture and software development methodology. The major method of implementation programming language are compilation, pure interpretation, and hybrid implementation. This is the basic and most important things when we go and develop any software. We need to take care of that. Which type of programming language we need to choose. This depends on our machine architecture, our software development methodology. Suppose that we need to create one particular web application. So in this scenario, either we use Angular, React with help of JavaScript or any web supported. In a backend, either we on the basis of our structure and system design, we can use Java, C#, and Golang and another backend support programming languages. And when we need to talk directly to the machine, just like when we need to create firmware software is the software which directly embedded in the machine. Just suppose that you have the washing machine, so washing machine also has the software. You have the fridge also has the software. That all the software which embedded in the machine itself, that called the firmware software. So when we need to create a software which directly communicate to the machine, we basically prefer C or C++. Now this is the end of the video. If you like the video, please like and subscribe and share with your friend. Thank you.